So first, I want to mention that you are attending the AI for Grid Resilience and Outage Management Optimization breakout room, and every time I talk to my students, say make sure that before you start the class, make sure you enter into the right classroom. Okay. Then very often when we talk about these two popular terms, AI and grid resilience, people may jump into a slightly different direction. So I want to, at the first beginning, I want to kind of lay down the foundation. We will talk is AI and resilience. And we will not talk is what is the definition of resilience and etc. Then the purpose for this conversation are three. The first one is, we'd like to engage more. We'd like to know you. And second is we'd like to know what's your perspective in terms of the challenges of applying AI for grid resilience for outage optimization. And the third objective is we want to identify, if we can, some collaboration opportunities among universities, EPRI, and the industry, different type of industry organization. So with that, I'd like to suggest we do that. Maybe each of us can have maybe a minute, kind of introduce yourself and your organization as a starting point. Then we can go to the second topic, which is help us to identify what the challenges you observed or you're facing in terms of AI application for grid resilience. Okay. Let me see. With that, I'll start myself. And my name is Liang Ming, and I'm with Stanford University. I run the initiative at Stanford called Bits and Watts. And the objective for Bits and Watts is how we can digitally enable the utility for the future transformation in terms of advanced modeling simulation, software and hardware, and apply the data analytics, machine learning, and AI to solve some problem cannot be solved by the traditional modeling method, and how we can help to introduce more advanced cybersecurity technology in the IT side, help the utility with IT/OT convergence, and etc. And it's my great pleasure to work with EPRI on this event to engage with industry folks. So I will stop here and see who'd like to go next.
Looks like we have Kevin and Jose 258 on.
Hello, my name is Kevin Collini. I'm with, I work at the North American Electric Reliability Corporation. And we've been doing some new software projects where we're collecting a lot more data. And I was just very interested in how to use that in terms of AI. But I also have a utility background, and your topics really seemed interesting to me, so I wanted to find out more about it. Thank you.
Great, thank you, Kevin.
So good afternoon. My name is Joe Rigatti. I'm a manager of nuclear technologies at Dominion Energy. We have nuclear stations at Millstone in Connecticut, North Anna in Surrey and Virginia, and VC Summer in South Carolina. So we are sort of at the very beginning of our data adventure. We are currently implementing electronic work package. We're implementing a monitoring and diagnostic center. We're participating with Idaho National Labs on a digital twin project. And, we are using a number of different drone technologies to help us with maintenance in the plant and inspections. And we are beginning a project to take a look at electronic procedures. But the whole culmination of this is getting the things that we do every day into data, and then being able to use that data to work on the things that are most important to work on. Try to shift to predictive maintenance instead of preventive maintenance, and make ourselves more efficient so we can drive down the cost of generating power. There are a number of things that have been talked about in the conference that are things that we are learning that we must deal with. Getting data in a format that's usable, validating that data is good data to work with, and then trying to create new models that help us understand where we're spending our money and how we're spending our money. So a lot going on, and it's exciting to see that there are others thinking about the things that we're thinking about and are working to help us find a way to become more efficient and be able to use what all this. It's kind of interesting, when you look at our nuclear units designed and built in the 60s, transition through the advent of computers, have terabytes of old data, some that's very valuable, some that's not valuable at all, but trying to find those nuggets of important information to help us understand how things work and how they interrelate. What's a predictor of failure and what is not. That's important stuff and available to us if we just figure out how to get at it. And it's the getting at that data and figuring out how to use it to our advantage that's the real trick.
Great. Thank you, Joe. Let me see. We have who'd like to go next? Amy?
Amy's actually part of the event team, so she
Part of the
will
event
be
team.
skipped.
Right, yeah.
Jeremy, do you want to pitch in? I think he's on a few different calls here.
Yep, I'm here. So, yeah, I'm excited to be on and really talking about some of the different areas around resiliency, outage optimization. Obviously, for me, all three breakouts are very exciting and engaging, but I work at EPRI, so I'm big into how we can help utilities in many different ways, but also really part of the purpose of this meeting is to bring people together to identify some of these big challenges where we can work together, some of the needs that utilities have, as well as some of the capabilities that AI vendors may be able to help us all with. So Leon, thanks for leading the session, and I'll stop talking so that we can kind of continue to make progress.
Good. Next one, Christine.
I think Christine is also in multiple meetings as well. I think she's supporting one of the other ones right now, so I don't know if she can hear us.
Okay, no worry. No, we have okay, I think that's all we have at this moment. And I think Joe has already started a very good kind of sharing a little bit of his perspective. And I think I'd like to get a little bit more from Kevin, since Kevin, you mentioned that you are collecting a lot of data. Then the things that interesting to you is how to use the data. So can you elaborate a little bit more, like what type of data you are collecting and what type of questions that you try to solve?
Sure. We collect outage information for generation and transmission across North America. And, I'm not, like we collect a lot of data. That's some of the data we collect. I don't actually work with that data. The work that I do is primarily right now with new registrations. And so I'm interested in, is there a way that we can, use models to improve registration based on data. So that's one thing I'm looking at, but I'm just generally interested. So a lot of the information in terms of outage coordination and stuff like that in my past is very helpful to what's important to the electric utility industry, mostly at the distribution level, it seems like, but also at the generator level and the transmission level. So I'm just very interested in that kind of information. And I think that I was looking forward to hearing more about that.
Terrific. So if I can press this a little bit more, you mentioned the generation and transmission. So I believe it's a gets data and tags data, right? The generation availability
Yep.
data sets and also the transmission.
Yes, that's
Yeah.
correct.
So actually, that's a very interesting at transmission level. A lot of data that is we call critical infrastructure data, and it's very hard to be shared, right? Then
Yes.
NERC has more than 40 years of gas data, and the test data is probably like 15 years or 10 or 15 years data. So that's a tremendous value among the data.
Yes.
And does NERC has any vision like how this data can be shared with the research organizations? More like help dig into the insights of the outage information. Also, without compromise any security or privacy issue for this data.
Yeah. I like I said, I don't work with that group particularly. I'm aware of their work, so I can't really speak to that. But I can put you in touch with them if you'd like to follow up.
Cool. Yeah, that would be very, very useful, especially for the transmission operation and the transmission planning research group, whatever at the EPRI or in other research organizations. So,
yeah,
because we heard very often, during the previous sessions, is when we do machine learning and AI, the first thing is also Joe kind of noted it as well, is getting the data. If we don't have the data, nothing we can do, right? And the second is really get this data organized, and then what's the value we can get out from this data. So good.
So I mean, I don't know if it's in scope for this talk, but I was just curious. Do you have some sort of use case for that data and AI now? Like, what would your use cases be?
I don't think EPRI has anybody from P39 or P40 programs here, but I can, through some ideas, especially kind of link you and Joe at completely different backgrounds, right? One is nuclear engineer, and one is more like a transmission and reliability coordinator. So, and in the nuclear sector, EPRI has a very popular tool called PRA, like probabilistic risk assessment. Basically is identify the probability of failure of specific equipment of nuclear, then identify what is the consequence of the risk. Because if you put the probability with the impact of the failure of the component, you can come up with the impact, the probability and the consequence. You can come up with a risk index. Then when we do on the transmission side, the existing NERC rule is all deterministic based. For instance, you have to comply N-1 or N-1-1. But the failure of the equipment, like transformer and generator transmission line, has different probability. For instance, like generation failure is more frequent than the transmission failure. And the single line transmission failure is more frequently than the bus bar failure, right? And how we can get the probability information among the 30 or 40 years generation availability data, and also the 10 or 20 years transmission availability data for the probability of the equipment failure. Then we can extend this, the similar idea, the risk-based approach, into the transmission planning and the transmission operations. I think that would be a very interesting idea, with my limited background in the transmission area.
Yeah, I mean, a lot of those studies are already, like there's actually pretty good information that can be gathered and studied already, and has been studied already. And so I kind of was curious, like, how to take those models and use them in an AI framework. I guess that's one area that the AI piece is kind of new for me, so I'm still kind of trying to catch up. But yeah, thank you for sharing that. That's very helpful.
Yeah, and Leon, if I can add something to that discussion, one of the companies that we've been discussing AI and outage optimization with is a company called Copperleaf, and they're looking at actually both different kinds of outages. So we kind of have two different types of outage. Oh, just sorry, I got some weird audio feedback on my side. So both types of outages, whether it's a transmission distribution outage or whether it's like a generation unit outage. So they have an AI tool that looks at not only probability of failure, kind of like you were talking about, Leon, with PRAs and different things like that, but also combining the data that you have with economic factors, maintenance reports, work orders, and different things like that to look at not only transmission distribution outages, but also generation side outages. So they have a tool that's kind of looking at both types of outages and how to optimize when to do those for optimum reliability as well as economics. So that might be something we can also kind of talk about and consider for the outcome of this meeting. And you'll notice that I think maybe everyone heard we have a WebEx assistant that's on. It's our little AI bot within WebEx. So if you want to tell it to record certain highlights, it'll do that for you. So we're using a little bit of AI within our AI meeting.
Interesting. Okay. Any other kind of challenges that you'd like to share with us? I know that Joe talked a little bit about that Dominion just get started on this digital transformation and the data team. So any other exciting things you'd like to share with us? So let me switch the topic. Let me switch the topic a little bit. And from we heard a lot about different models, different methodology of AI. Then the things I would like to ask is more on the hardware side. So how, like the utility or the organization you have, so what kind of hardware infrastructure you have to prepare for the high volume of data is already coming or is going to come to the utility domain? You use the cloud, are you comfortable with that? Or you have to buy a lot of storage devices? So what is the existing practice in your organization of dealing and store the huge amount of data? Or any challenges?
Yeah, so for Dominion, we have solutions that are both in the cloud and not, nuclear not, mostly because we're uncomfortable with it. And our cybersecurity requirements do not make the cloud an available resource at this time. On generation side, there is some integration of the cloud. We're finding some very significant issues with getting data from our facilities to corporate center. As we're learning a lot about getting data in the right format and the right bandwidth and how much traffic there is, and trying to make it so that we're able to do some amount of AI associated with equipment performance.
Okay, Kevin, anything you want to add?
No, nothing in particular. This is, for our organization doesn't, we're not collecting like data in the same way a normal utility would. So I think it's just a different application.
Okay, got it. I think we have another participant, and Wesley Jones. Can you quickly introduce yourself?
Hi, yeah, this is Wesley Jones. I'm from the National Renewable Energy Lab. I work in the Computational Sciences Center, but have a lot of interaction with different domain scientists, especially in transportation and the electric grid control in particular toward optimizing system performance, projects in resiliency, and using exascale computing as well as several projects and a lot of staff who are our artificial intelligence kind of group at the lab.
Good. I think this is perfect timing you joining us, since there's a question we're discussing is regarding what is the infrastructure we need to handle the volume of data that the utility is already received, are going to receive. So from national lab perspective, can you share with us in terms of the pros and cons of high-performance computing versus cloud? You may heard a little bit about Joe's, the input, especially for AI application.
Yeah, no, I mean, so it's interesting because we work on projects that we host a petascale or a decapetascale computing system for research, and a lot of that research we do in the electricity system is how do we scale up the applications within that framework? How do we take advantage of many processors and many nodes? And there's different ways of doing that. Of course, there's optimization, like a Gurobi solver only really uses like a couple of cores. And so there are things you have to do in your formulation to enable you to take advantage of parallel computing algorithmically. And of course, and one of those ways is to move away from optimization proper into artificial intelligence, something like reinforcement learning, where we can simulate many copies of something to learn how the system operates and how the system in particular responds to different operational principles or needs. And so those are the places where the high performance computing can really be useful. And I think that one of the things that maybe is less talked about is the way that one of the things that artificial intelligence does is it can move the computing bottleneck from the end, from the device or the thing that you're trying to do into the HPC, so you learn a deep neural network about a system, and then you can use that either on an accelerated system for inference or on some other system. And so that's one of the pieces that we try to use is how can we leverage these high performance computing machines to learn things that can then be used off the HPC. And I think there are phone apps that kind of show that, where you have like a phone app is running the neural network necessarily, but it's giving you information, but it's learned from this huge data set. So then our group, our center also hosts the cloud infrastructure focused on research in the cloud. And so it's funny because our most secure systems for carrying out research are in the cloud. And that's because when we create a high performance computer, we have a shared file system. And of course, shared file systems are like an Achilles heel to like moderate level security. And so in the cloud, if you work with a FedRAMP provider, they have the hardware on which you can build moderate level secure systems to do your research. And so that's one benefit we actually see of the cloud is that agility. And of course, when you're using a cloud on a day-to-day basis, the cloud is kind of like just a group of Linux servers that you're orchestrating. And so, sometimes the reason to use the cloud might have to do with data that you want to make available to the public via some middleware or web interface. For instance, we have simulations to involve solar and wind resource. And so we run that on our petaflop system to produce backcasts of weather in the US at very high resolution with output consistent with grid operation. That is 5-minute in many cases. But then we have put that in the cloud so that different people from around the world can have access to that data, and they can do it with a relatively high speed. Especially if they instantiate their own cloud resource that's consistent with our cloud provider. And then we have some projects where we create these hybrid systems where we are collecting data at the edge in real time. So you have all of the edge devices that are taking data. Some of them are actually running artificial intelligence algorithms that only give us then metadata that are counting things. We can then aggregate those in the cloud, and the cloud, if you put up the right apps, those applications can be scalable. And so then we can run algorithms for orchestration of those edge devices. And then the person who might be in charge of providing a service can use either that data or the outcome of that orchestration to inform near real time operation. Right? They don't have to take it, but they can. And we've shown some energy reductions in that kind of a hybrid computing environment where there's kind of the edge, the cloud proper for data, and HPC in the cloud for the algorithmic utilization. I don't know. So those are some thoughts.
Good inputs. Any response, Joe, you may have? Okay, very good. So I have one quick follow-up. So, what's your perspective? Because utility, that do they need high performance computing like National Lab has? If so, what's the size of HPC they may need in order to take advantage of the advanced AI algorithm for specific application? Of course, the application can vary a lot, right? And different application may have different requirements of the hardware. But what's your perspective? Either do they need high performance computing or the cloud structure, be able to support their need?
Right. Well, so the thing is that high performance in computing and cloud are not in the same category. They're actually a little bit there's a grid of there's like cloud services off premise, there's HPC in the cloud off premise, there's HPC on premise, and then there's cloud on premise. And so they're not so simply so I would say the question isn't so much do you need HPC, would it fit in the cloud or not, as much as it is part of it is I think that like part of it is putting in place a scalable mechanism to allow your staff to innovate and show the value of high performance computing. I think that's one thing that my group excels at, which is kind of like showing the value of the high performance computing by showing value in, if you used high performance computing, how it might impact the system, like directly showing what would be the value of stochastic optimization, right? And so for stochastic optimization, one way to pursue that is scenario-based stochastic optimization, which can then run in a scalable fashion, which then can utilize these high performance computing, whether they're in the cloud or outside of the cloud.
Good.
I would say that a utility could use a high performance computer, but I think the way to use this high performance computer is to figure out how to enable your staff to have access to some scalable frameworks so that they can show the value internally of using parallelization. Sorry, long-winded answer.
Great. Let me switch the topic a little bit, talk about the workforce or stuff, because I think Wesley, you mentioned that, you get your stuff ready or energized, do something. So what's your perspective about the training level of your existing colleagues or engineers of AI, advanced data analytics, and be able to take advantage of this knowledge to help your specific operational business in your organization? Are they ready, or they need more training, or what's your perspective on that?
Are you asking everybody? I'll just chime in here. One of the things that we found at NREL is with respect to like computing, math, data, visualization, artificial intelligence. One of the things that we've done is established like a core group of people who who have like a dual role of being a champion and a consultant in that area, as well as carrying out the research itself. Because what we found is that even though, in the organization, we might own all of something, like own all of AI or machine learning, that really it does our organization a lot, gives our organization a lot more value when the whole organization is empowered to use computing and to use artificial intelligence and machine learning. And so like the people that we have in our organization maybe could host seminars or workshops on artificial intelligence, machine learning, but what we found to have more value is reverse or I think they're called flipped classrooms, where we find topics that people can take courses in and then work with the domain scientists or the staff that would like to use machine learning and artificial intelligence potentially in their research to work through some of the elements of it together so that they can become knowledgeable about where it might be utilized or how it might be utilized. And then to give them just enough knowledge to be dangerous and access to people who can help them along the way so that they can develop themselves. Because I think part of workforce development isn't like, there's certainly like training new people, but often there is pivoting people who are in your organization who have some initiative to move to something new.
We sort of addressed that for us by creating a citizen data scientist training program. We just initiated it, where people who have an interest, but they're not data scientists, they have an interest in that, will get trained by our IT data scientists to do certain kinds of programming, data analysis, and help support the transition to artificial intelligence stuff. I would expect that that will bear some good fruit for us, because it really helps that part where the people who use the data every day and know what it means can help relate to the scientist who's going to take it and mold it in different ways to help us understand what we're seeing.
Yeah, kind of like in that frame, one of the most powerful frameworks to enable that for us has been the Jupyter Notebook, because the Jupyter Notebook can really enable our data scientists, machine learning experts to create customized interfaces for people who are traditionally analysts, but the nature of that is it can be kind of like arbitrarily simple and arbitrarily complex, right? Because one of the things is sometimes you create an interface and it's too simple, so then the analyst can't really use it, or it's too complex and they can't use it. And that interface allows you to launch something that's relatively simple, but it has the code right there underneath it to enable the person with some initiative to start modifying and take into account, just like Joe was saying, their own domain knowledge. They can recognize what things are. They can come up with new views. They can add new fields. They can see the relationships between things that people hadn't thought of. They can quickly identify anomalies, right? Sometimes it's funny how often data scientists will only find the anomaly in the problem and not the meat. And there can be so much more to it.
Good, good. I think we have another participant, Cheryl, and just give you a little bit background information what we have discussed. We're discussing now. So we're discussing the workforce needs, and we have discussed a little bit about the challenges of applying AI for the resilience for any other application in your organization, and also we have touched a little bit on the infrastructure, the hardware or the cloud infrastructure needs of taking advantage of AI. So for the benefit of the whole group, maybe you can just take maybe a quick a minute, introduce yourself, and feel free to share any of the perspective you'd like to share for these three topics. Can you hear me? Sure.
You're muted.
Oh, yes, I was just unmuting there. So let me do the video. Hopefully that's coming through. There we go. Yeah. Thank you for addressing some questions to me, and also I really wanted to say I just got into this session, so I was in the other breakout session right before that, so I only caught a few minutes. But earlier today, I was paying attention to the presentations, and I did have a few questions that came up, and one, I have a more general higher level approach because of my previous role at Department of Energy as the AI director. But so I'm always looking at it. I think a lot the way that they do it at EPRI, right, is how can we all share these data sets better? How can we all share the algorithms better? How can we share lessons learned? Could we put together a workflow that maybe works for most, most of the group, but it maybe has to be customized, for each utility somewhat, but it could be configured. And, when I think about how businesses operate on, like an SAP platform and also the government, and you think, well, why wouldn't this be possible that we could have some, AI programs and AI data sets that we could all use for resilience in the grid, and in a way to build redundancies as well. And even today, as there were several discussions on digital twins, I think there might have been a session yesterday as well on digital twins, but it really raises the question, can we somehow protect ourselves from some of the worst of these cyber attacks, like ransomware, where all of the data is, access to the data to run an asset is shut down? Is there a way through digital twins where we have, the really exact same data set, that we could do that more broadly, that we could run the system when, when we're under attack? I mean, earlier they were talking about that they had built, I think it was in France, they had done a grand challenge and had really kept the system up while there were malicious cyber attacks taking off parts of the network, and then they would bring them back on. But that's a little bit different than some of the worst of the cyber attacks. And so I also have some questions to pose, I guess, if that's okay, to the group. Is there any thought about how to approach resiliency when all of the data and the operating system is taken out of control,
Anyone like to respond to that? So I can jump in, try your first question regarding the data sharing. I think we'll talk a little bit about here. There are two things. One is the algorithm, right? The benefit of algorithms, most of the advanced AI algorithms, they are open source. If you go to the OpenAI or others, or DeepMind or Google's, you will see tons of open source application of AI. And the real challenge is utility data, because utility is responsible for the reliability of the electrical system. A lot of data, which is sensitive information or critical, we call the critical electrical infrastructure data, CERI data. And this data very hard to be shared publicly. Right? And how I think EPRI or DOE or NERC and DHS can really work together to create a comfortable zone that utility are willing to share the tremendous data they have collected. We heard from Kevin of NERC, the 40 years generation availability outage data and the 20 years transmission outage data they have collected can be shared among the community, and also shared with in a trust way and a secured way with the research organization, so that the advanced application can really help the utility to move forward. Then on the flip side is another perspective is really on the distribution and the customer side. This is not a federal footprint, it's more like a state footprint. So the state and federal and the research organizations really work together to help unleash and unlock the tremendous data from the distributed resources, and also need to address another issue, which is privacy issues. There's a lot of advanced techniques available in the healthcare industry. They value the privacy much higher, actually, or maybe equivalent or much higher than electricity business. And they are able to share the data with the researchers. Now, how we can, state and federal and the research organization, to create a comfortable zone, be able to address the privacy, security, and the reliability of the distributed resource data. That's also a very important perspective. So I will stop here and see anybody else would like to jump in.
Yeah, I just comment on that is that, we did something on a similar level. It was with healthcare data, but they, had all the IRBs and the whole process already set up. And of course, sharing through multiple organizations, it took a long time between, the lawyers between each ones to come to an agreement. But when we did, then it was, we were actually able to share that data. And again, for research purposes. But yeah, it seems like if we could set that as a goal as a group and commit to it, then it really is about the execution.
This is Wes Jones. I think that from ANREL, I think that one of the things that we could do, as a parallel track is to enable the use of AI to create synthetic, synchronized, anonymized data sets that could be shared even more widely. I know, it's hard to know which track is harder to create the trusted environment that people can do research, because you still limit who's allowed to have access at that point. Or to continue down some roads about synthetic data. We've found like a huge amount of value in some of the synthetic representations of power systems. But of course, those synthetic representations are, they need to be like a living piece of data where they can be informed by other pieces of data that would be, that are available to the utilities that they could use. And I say synchronous too, because, if you're trying to, understand correlations between temperature and load, it doesn't make any sense to have a synthetic model of load that's not in the same hour and minute as the synthetic data of weather. So those can be some challenges. And I think that there's a lot of challenges in a lot of places where that, even outside of electricity, where those could be some really good things. I also wonder on, when we work on our electric grid studies, often we're very focused on the economic and associated optimal utilization of the resources to drive the economics of the circumstance. And of course, some of my research is like, AI for resilient systems. So something has occurred on the grid, and so then you want to be able to operate it with AI in a resilient fashion, and that's really has a lot of promise. But there is also underlying some of this going to the question about what if there's no data available? So we rely on data when we make our decisions in an economic place. But one of the things I think we forget is that the grid communicates with itself at nearly the speed of light. And there could be processes and mechanisms that don't give you the economic execution of the electric grid, but it gives you an operation that allows you to operate critical infrastructure, but it's doing it by following the pulses of electricity that are occurring they're occurring, in the physics of the system. We have like some research for detecting faults before those, before you burn your transformer up, right? And so you have to detect that fault in less than a cycle of the frequency, right? In less than 240th of a second. You want to be able to identify these faults in the system and then respond. And there could be pieces where AI might be on some of the end devices, so that their principal connection is through the electricity of the system itself, to help with that worst case scenario, as opposed to responding afterward, doing it in some economically efficient and optimal way where data is actually available, or to maybe even have some ideas around data governance where things are separated, but you just have enough information that you can, black start an island and allow critical infrastructure to operate.
Good. Good. I see we have another participants join, and we have about 10 minutes left. Maybe John Lindberg, can you just give us a very quick 1-minute introduction of yourself? then we can go to Cheryl's next question that Wesley had already touched a little bit on the resilience. John, can you hear us?
Yes. Yeah, my name is John Lindberg. I work in the nuclear sector of EPRI in the NDE group. And we've been involved in data analytics and AI activities probably for 4 or 5 years now. But, a few of the things that we're looking at primarily are in the area of automating the analysis of non-destructive examinations. And some of those areas, 2 of those areas have been primarily in remote visual examinations of reactor internals inspections, and then also remote visual examinations for fuel inspections. That work was actually being done through our nuclear fuels group. And then we're also doing work with looking at automating the analysis for the review of data that we're now collecting through doing remote visual examinations using drones for visual inspections for the containment structures and other concrete structures. So some of the challenges that we've had in doing the automated analysis projects is with the data. And initially, the data that we used for the automated analysis for remote visual examinations of reactor internals was data that we had internally that was taken from actually remote visual examination test specimens that we had fabricated in-house. And those test specimens had flaws that represented, flaws that were actually in the field. So they were fairly representative of what was in the field. And they were also, pretty much under control that, we knew the size of the flaws, the types of flaws. So they were cataloged fairly well. But then as we progressed with trying to machine learn with the data, in actual use of field data, we found that the problems, the challenges we had with the field data was the fact that it did not have a lot of flaws in the field data, which is, of course, a good thing. But, when you're trying to machine learn with the data, you basically have, a disproportionate amount of unflawed test area to flawed area. So it really, affects your ability to machine learn. We've done a number of things to try to address that. One of the things we have been looking at is the use of synthetic data. And I believe we'll probably use that more in the future, but we need to really take a look at how we will use that in conjunction with existing data sets and the field data sets. So that's kind of a brief of some of the things we're doing.
Good. We only have about 5 minutes left. Let me kind of combine Cheryl's question and also the question I have, because the goal for this one is really try to identify what is the most interesting idea or challenges in this topic, AI for grid resilience. That could be a specific application, or could be a infrastructure hardware issue, or could be a workforce issue. So I would suggest we do a rapid fire. Each of you participate in this conversation can give us very quick, like 1 sentence summary. What's your view of the most interesting problem in the AI for grid resilience? Would you like to start first?
I could start. I think one is how to maintain operations when under a cyber attack.
Good. Cyber attack on the operation, for the grid on the operation. So my shot will be how you link the 3 sectors, which is climate data with electrical grid data, because climate data very important for to know where the potential threats will be, extreme events, linked with the electrical grid data, with the social science data, to really protect the vulnerable area and underrepresented communities. Like to go next. Kevin, Joe, and Wesley. Did I miss anyone?
Yeah, I liked both of those topics. I mean, for us, it would be a little more focused on like operations of autonomous distributed energy systems under attack. I like that kind of a topic on the one axis, but I also really like the topic of the the optimal planning for addressing climate mitigation, grid operations, and social equity. I think there could be some really interesting data fusion questions, how all of that is done together toward building the infrastructure that would be required to achieve it, to have that.
Good. Any other volunteers?
I'll go. I mean, I'm still relatively new to this area, so I think I'd be most interested in is kind of seeing like at the distribution, transmission, generation, and regional areas. Looking at it in terms of like where can highly advanced automation occur, both in planning as well as in operations, in real-time operations. I think that's pretty fascinating.
Okay, last call. Anyone else would like to throw idea here?
Last one. So for purely selfish reasons, I'm mostly interested in the ability to use AI to be able to make predictions about equipment performance so that I can refocus my outages on the most critical items, avoid work on things I don't need to do work on, and improve my overall efficiency. AI is I think it's going to be a great tool for helping me make good prediction on equipment performance.
Okay, terrific. With that, Hannah, I'd like to hand this back to you to conclude today's conversation.
Great, thank you so much. All right, guys, we will be back on the microsite tomorrow morning at 9 a.m. Eastern time. You will get an email at 8, just like you did this morning with the link to join. But I think other than that, we're all set. This session was recorded, so we will be posting that to the site later this evening. If you guys have any questions or comments or need anything else, don't hesitate to let me know, and we will be all good to go. Thank you.